So I'm going to talk about Git and GitHub. These are pretty essential tools for people in computer science, because even if you don't end up using this particular version control system, you'll end up using some version control system at some point in time when you're working with somebody else. I'm mostly going to talk about the free version control systems and just briefly touch on the history of them leading up to Git. But there's also proprietary systems. There's one that's like built into Visual Studio that Microsoft built. Visual Studio also supports Git, of course, and SVN. But anyways, about version control in general. Version control, it tracks the history of the files. So what you might be doing now if you don't use version control is making a copy of your homework1.c file, homework1.back, homework1.backup2, homework1.backup3, and so on and so forth. And this provides a bit more of a methodical and structured way to go about doing these things. You can easily view the history or revert changes that you've made at any point in time. With remote repositories, you can push all of the history that you have locally, every version of the file, to some remote server, and then if your laptop dies, you can get back that entire history. And many people use it to share their code publicly. So if I'm writing like some free software in my spare time and I want people to go use it out across the internet, it's really easy to distribute software by GitHub or by some other Git repository and allow people to get it. And like I mentioned, it's how teams will collaborate on projects, whether in industry or in groups like the CAD or the ACM here, or just working on projects across the internet. So a couple core concepts to cover is that a repository is like an authoritative central place where the history is kept. So in some version control systems, you just have one central place. With Git, you can kind of have multiple, and I'll try to explain that a little bit better in a second. Then you have your checkout or your working copy. These are the files that you're editing and working with right now, but they're not necessarily like checked into the repository. They're not in the history yet. So there's a point where you actually make a mark on the history and commit them. That's called either a commit or a revision, and it's just a checkpoint in the history. It'll have the date that you did it, the person who made the change, and you might put some short message describing like what you did or why you made that change. So the history of version control goes back pretty long. In 1982, they released what's called RCS. It's just revision control system, and it was for tracking a single file. It was basically the equivalent of doing backup files. And so you could track on a single system, a single set of files amongst whoever had access to that system. Then in 1990, they released CVS. That introduced a centralized model where there's a client and a server. So I can be a developer with my laptop, I can connect to the server, check out the code, and then another developer, maybe on the same floor as me or maybe across the country, connecting through the internet, can also connect to that server and check out the same code, and we can push our changes back and collaborate in that way. SVN came almost 10 years later in 2000 with a little bit better usability but no groundbreaking changes, and then it all changed in 2005. This is when distributed version control came out. So Git, Bazaar, and Mercurial are some of the big ones, and they allow the collaboration to happen more decentralized. So if I make a checkout of code from a distributed system, then my working copy actually has the entire history there at my fingertips. And so if I take my laptop offline, I can still browse through the history without connecting to the server. And it allows multiple people to have a single central copy of that repository, which I'll explain a bit more in a second. So with like revision control system, this is kind of the equivalent of what you might be doing if you're saving multiple copies of your file on your computer. You have one main file, you have some database of multiple versions. With a distributed system, you end up with a server and it has the complete history, and then every computer with a checkout of that particular repository will have the most recent file and every version that led up to it. Other things you can do is you can tag a commit that gives it like a special name. If you're going to release like version 1.0 of your software, you'll do a tag to mark the particular commit where 1.0 happened. You might also do that if you're like drafting over a paper and keeping it in Git. Some people will use like LaTeX or something to write their papers. and then you could like tag different parts of your revision process. The fun part of version control happens when you start using branches. So branches are where you can deviate the history. Let's say I'm working on something that's really important and I have a deadline next week, but I have a fun idea and I want to try something out, but I don't want to like compromise my ability to get that thing done on time. So what you can do is you can create a branch in the history for your experiment. You can work on whatever that is, and then if you decide that was a bad idea, I need to go back and work on my original stable code and just get that done, you can switch back to your original branch. Kind of similar to branches, but one level ahead is a fork, where you can take the entire history of a repository, all of the branches, all of the commits, and make an entire copy of them. So I'll explain that a little bit more later. GitHub is an online platform for collaborating with Git. It's decentralized, so you don't have to just use GitHub, and if you get a project off GitHub, you don't even need to keep using it on GitHub. You can use it on one of the other providers. But GitHub is the most popular one. Anybody can create an account, and anybody can have unlimited public repositories. And then people can fork each other's repositories. So that's why GitHub is really popular, is a lot of people are using it. And so you can go on, if you use like the Ruby on Rails framework, you can go on and you can make a fork of their repository. You can make changes in your own repository of Ruby on Rails. And then if you want them to accept your changes, without being an official developer or any part of their community, you can then submit a pull request back to them. They can review your changes without even having met you and choose to accept them. So this also really allows the barrier of entry in distributed projects to go down, because you don't have to have built trust and gained access to their centralized repository. You can just fork your own, go work in your own little bubble, and then they can go look at your changes and decide whether they trust you, whether they want to accept those changes, and eventually give you access to their own main repository. GitHub also offers something really cool for students, which is called their developer pack. It steals not just from GitHub, but from a lot of big tech companies. So you can have 5 private repositories. And private repositories are really important when you're a student, because I actually had a friend in my capstone group who got called in by a professor for cheating, and what had happened was he was just using a public Git repository for his homework, and another student had searched for the code online to see if he could find somebody else's answers, found his code on GitHub, downloaded it, turned that in as his own work, and so he had to explain. Obviously he didn't get in trouble once he just explained that he was using GitHub. But as a student, if you don't have clearance from your professors, you'll want to make use of the free micro account that's available. You just have to use your student account and submit a picture of your ID card. And then you can have private repositories on GitHub too, and keep your homework protected from getting in any trouble for cheating unintentionally. But also with the developer pack, you get a bunch of other free stuff. DigitalOcean provides virtual private servers, and you get $100 credit. And you can get a free ME domain from Namecheap, continuous integration builds for your private code, Visual Studio, and a bunch of other stuff. So that's really helpful. But now I'll walk you through just making a basic GitHub account. You can add the student stuff later. If you want to go to github.com, all that you have to do is pick a username and enter your email address and a password. Does anybody here already have a GitHub account? Okay, so I guess most people are actually ahead of the game. But yeah, so just fill out some username. And password. If you have an account, you can just sign into it. So you can click sign up and it'll sign you up. I'm not actually going to do it because I already have one. So like I said, be careful about pushing assignments publicly. You can upgrade your account later with the student stuff. But once you get a GitHub account and get signed in, all you have to do to create a repository is go down and find the new repository button under your repositories. You give it some name, and you usually don't want to, like, you can't include spaces in this, I think, and you don't want special characters, just something simple. And you can optionally add a description. For now, you'll want to choose public, otherwise it'll try to charge you money. And then you can just create the repository. So if you create a test repo, it'll give you a bunch of instructions. I'll go through that process. So I already made one. So if I create an example repository, it'll say that I have a number of ways that I can precede this. So I could create it on the command line. If you have existing code, like if somebody gave you a Git repository on a thumb disk or something, you could totally just take that and then create this repository and push the code to it because of the distributed nature. And then you can also import code from elsewhere with GitHub, a different type of version control repository if you preferred using Git. But so I'll walk you through what this exactly is doing, creating a new repository on the command line. The first thing that you'll want to do is you'll want to make the directory for the test repo. So does everybody know how to open a terminal, or does anybody need help opening a terminal? Okay, just wanted to make sure. So you make the test repo directory, and then you change directories to the test repo directory. And so this is just an empty directory. I could have some files here. If I had been working on a project already and I'd wanted to import it into Git, I could just jump right in and do the same thing with my existing code. But first you initialize the repository by doing git init. Git init will just create an empty repository here. And by default, it makes only one branch called the master branch. This just represents your main line of history. And if you don't do any interesting branching, you can continue to use it in that way, and it'll be perfectly useful for you. So after running git init, we've just created this empty repository. We can now create a file by saying like echo testing into readme.md. And all that does is creates the readme.md file with the word testing in it. So you could have done that with like a text editor or anything else. But at that point, you need to tell Git that you want it to track this file now. So you say git add, and you say git add readme.md with the file name. You actually have to add it each time you make the change. What you're doing is you're adding it to be staged as part of this next commit. So you're saying to Git, I'm about to commit this point in history, and I want to add this file to be part of that commit, whether you are adding it for the first time or changing the file. So now it's staged. You can run git status, which kind of gives you an overview of where you're at. It says that I'm on the master branch, which is just the default mainline branch if you're not doing anything interesting. It's saying that I'm going to make the initial commit because I'm just starting out the repository. And then it's showing me the changes to be committed. And it's saying that the only thing here is a new file, readme.md. It gives some hints, like if I wanted to unstage it to make it not part of this commit, I could do git rm-cached with the file name. So Git kind of tries to give you hints and help you through it, because there's a lot to take in. But once you get a mastery of the core concepts, it's really flexible and really powerful. So from that point, we have this new file. It's about to be committed. We just say git commit. You could run git commit like this, and it would open up an editor, probably Vim by default, and you could enter in a message to describe the commit. Or you can do git commit -m, so you could just give the message on the command line. So I'm just going to say I added a readme, in quotes. And with git commit -m, it'll tell me now it's committed as the root commit to the master branch. The message it used was added readme as I told it to, and it created this new file as part of that commit. It just shows a brief summary of what has changed. So at that point, my local repository has this commit saved, this point in history. But due to the distributed nature of Git, it's not actually on GitHub yet. So that's kind of a bit of extra complexity that's added by the distributed version control systems, in that now there's an additional step. You have to say git push -u origin master. And so what that says is git push says push a branch to a remote repository. -u says which upstream repository to use. So origin is just the default. And so that would be the GitHub that we added. And then master is which branch to push. So master is just the default branch. The same way, but the URL, oh, I skipped a step, I'm sorry. That might be why it didn't make sense. So we have to actually add the remote. We have to say git remote add origin. And so this actually tells it what the origin repository is. So here you give it the URL to your GitHub. The GitHub repository URL is either the one GitHub tells you to, or it's actually just the URL that's up at the top when you first visit the repository. No, it's optional. So it's kind of nice. You can use either way. So right, you have to get remote add origin first to tell it to associate this URL repository with the name origin as a remote. And so then, that would have been the same no matter whether you're on Bitbucket or wherever else, just specifying the URL. And then you can push to the upstream origin, which it knows by that URL, and the master branch. It'll push your local master branch to a remote master branch by default, but you could do something different if you had multiple branches. That probably will make sense as you start using more things and as you do, like more interesting patterns build on the simple patterns. So here it'll ask you for your username and password. You can set up SSH keys to make that process automatic, so it'll just do the authentication for you. But that's a bit of a different can of worms. So with the username and password now, it'll say it's pushed a new branch because there wasn't a master branch on the other side, and it pushed over however many objects, 3 objects in this case, like 1 for the commit, 1 for the file, 1 for the directory probably. And it says that it's set up master to track the remote branch. So what that means is now if I do a push or a pull, by default it'll know to do it from there. So basically what we did is we created a remote repository when we made it on GitHub. When we came back and we did the git init, we made an empty local repository. Then we added a file and committed that file to our local repository. Then we added the remote repository to be associated, and we pushed our commit to the branch there. Are there any questions yet?
Go back to one screen.
This one? Or?
The light one.
Gotcha.
Does this work only with Linux?
What's that?
Does all of this only work with Linux?
It's probably a little bit different on Windows. I know that there's definitely like graphical clients on Windows, and you can install this client on Windows as well. So it works there, and on Mac, I think it might come with Mac, actually.
So GitHub
I'm
has
not
a
sure.
client that-
What's that? Yeah. Yeah, I think it might actually come with Git nowadays, though. I know it used to come with SVN. Anyways.
So does Windows have some kind of a GUI to do all this?
Yeah, I think there's a couple different ones. Yeah. Did you create that file? Oh. So first you do git add readme.md. And so then you can do git commit -m with the message. Git is kind of interesting in that there's your working copy, which is the files actually on disk, and then there's something called the index, and that's what's staged to be committed. So you do git add and that says that the file I have working on my disk should be added to the index, and then when you do git commit, it actually copies everything from the index with that commit message and this timestamp into the repository history. So it's kind of a two-step process. First you add the files, then you commit to actually move them from the index for their stage to be committed into the repository history.
Can you also work directly on GitHub, like directly on the website?
Yeah, you can edit.
Instead of doing it offline and then committing it.
Yeah, you can edit files directly on GitHub. It's a little bit of a different interface. I don't find it as intuitive sometimes, but we can walk through that in a second. Actually, we can do that now. Let me see if I can find it. Let's see. Yeah, so on GitHub interface, you can actually just delete files here or use the little pencil mark and add more edits. Give it some message, updated the README, and commit it directly to the branch. You could have made a separate branch, like I said, if you'd wanted to do something more interesting. But so that made a change directly to the repository on GitHub. I usually only use that for like documentation changes with the READMEs and such, because code I always want to test first. But from here now, you can go to the commit history on GitHub, and you can see this is the commit I added on the command line and pushed, and then this is the change that I just made. It shows that originally there was this testing before this extra commit happened, and then these two lines shown in green were added. Now that I've made a change in the web interface, the version of the file that I have on disk isn't any longer up to date. So since we've already associated these branches to each other, I can just say git pull. Git pull, and it knows where to pull it from. And it pulls down that new commit and it updates the file on disk. So now I have the change that I made in the web interface. If you're working with like multiple computers and you have the repository shared between them and you're pushing it to GitHub, all you really have to do is make your changes in one place, make sure you remember to push them, and then when you get to your other computers, make sure you pull your changes first. And then you know that you won't ever have your versions out of sync, as long as you always remember to push when you're done and pull when you start. Every repository will always be in sync. So some of the other things that you can do is when you first want to get a new copy of this repository that we already have existing, you'll just do a git clone rather than like the git init. Git init was to create the empty repository, and then we could add some changes and push it. That's only something you do the first time. So if I wanted to get a new version or a new copy of the latest version of my repository now, I could just use this git clone command. Then, like I said, you make any changes, any files you update or add, you use git add to add them in. There's similar command git rm to remove files if you didn't want them anymore. And then you can commit them with git commit, give it the -m flag and a message. Yep.
Does the git remove the history for it too, or does it keep it up to that point?
No, so actually what the git rm does is it removes the file in the index, and then as part of the next commit that you make, that file will be removed. So it'll be in the history shown as being deleted at that point in time, but the entire history still remains. The interesting thing about Git is that it's actually kind of almost like a cryptographic verification of the history if you have a commit ID, because the commit ID is actually a hash of all the information that came before it. So you have like verified integrity of the history with a particular commit, and all of the previous history leading up to it actually has to be there for that commit ID to be calculated. So you can never go back and like compromise the history without rewriting the entire history leading up to this point. And for that reason, it's kind of also a security measure in the Linux kernel. That was one of the design reasons that Linus did it, is so that he would know that nobody went back and tampered with the history of the Linux kernel. So anyways, when you're done, you push, when you start out on a new computer or when one of your collaborators wants to pull down your changes, they do a git pull. And that's the basic workflow. Yep.
What's the difference between pull and clone? If you don't have a repository on your local machine,
Right,
if
clone.
you pulled, it would be the same as clone, wouldn't it?
Yeah, pull just takes any new updates from the remote repository and it updates them into your local repository. But you have to have already had that repository. So the first time you clone and then subsequent updates are done with a pull. So other things you can do is you can run git log on the command line to show the history, kind of like I had done in the web interface. It shows where I updated the README in the web interface, and it showed where I added the README on the command line. It shows the date and the author, so if you're working on a team, you always know who made changes. You can also do git show with this unique commit ID. So if I copy that commit ID and do git show, it shows me what changes I made. That's probably far down on the screen. But it shows similarly in green with plus marks the lines that were added, and it would show with minus signs in red anything that was removed. So you can really easily inspect the history. Other interesting things is like you can do blame on a file and it'll show you when you added a particular line of code, even though this is way too zoomed in. And you can use a tool called git diff to compare different versions. So there's a lot of different ways to manipulate the history once it's in there. And it's a really flexible system, so there's a lot of ways to add to that history and to like do branching, tags, track history in different ways. One of the things that some teams will do is you'll have like your master branch, and then I said you can branch off of it a separate line of history if you're working in an experiment. But some teams will say everything's an experiment, and so everybody, any change they're going to make, they make a separate branch for. And then when they want that branch to be merged back into the mainline master branch to be part of the code that everybody uses, they actually have to submit that request and have a different team member review that code and merge that code in for them once they find it of acceptable quality. So there's a lot of different ways that you can make use of these branching techniques and all the different workflows available. And there's really just so many different ways people use this stuff.
So they're merged command, so you end up like wanting to use this branch and transfer it over to your main branch?
Yeah.
Or something, or like if you end up having somebody do some changes to this, to one branch and to the main branch, then merge both of these after they already have changes happened?
Yep, so basically what happens is if I want to make a new branch, I say checkout -b and give it a branch name. So that's like new branch. Now I can do git checkout master to get back to master, git checkout new branch to get back to new branch. If I make changes to my README file and I add it and I commit it, I can now, this commit was added to the new branch, and I can now check out the master branch and merge in the new branch. And it'll just say that it was able to do this using a fast forward. If there's like a conflict, it might stop and have you resolve that conflict. Or if there's something really interesting that it can resolve with a more complicated algorithm than just a fast forward update, it'll do some of that automatically sometimes. And it'll just show you what it changed and show you the updates that happened.
So what would one of those conflicts be? Like instead of just adding more things, you go back and showing?
So like if I delete a line of code and I commit that in my branch and then a coworker deletes that same line of code, Git will usually consider that to be a merge conflict because we might have replaced it with different lines of code. And so if it just adds both of those lines of code next to each other, it might not be the desired effect. So that type of thing, like the same lines of code, similar code, but it really works out a lot of it automatically. It's pretty intelligent.
So when you merge these branches, it's not just saying, so the new branch has all of your new things and just like puts it right on top and destroys the other one. They're actually
Yeah.
like leaving
Yeah.
credit.
Yeah.
How does it know how to do that?
Kind of just intelligence, like it works out where the changes happened and figures out what it can do. On the other hand, I'll show you, let's see. Oh, I guess this isn't too interesting. So in this case, it was just a fast forward because there weren't any other changes happening in the master branch. So it just put it on top basically and said, okay, now new branch is master because that's basically equivalent history. But if they had diverged, it would make a new commit where it resolved the differences. And so you would still have both commits in the history. You would see a fork in this line, and then you would see a merge commit where they come back together. And if it's a merge where there was a conflict that you had to resolve, some of the changes in that commit would actually be things that you manually did. Like Git will show you, this version had this version had this, and you'll have to edit the file and like pick which one. Yeah. But otherwise, the merge commit will just show the changes that Git automatically made to resolve them. And it'll just be a commit bringing the two histories together, basically having two parents for that particular commit.
Even after the merge, you can go back to previous points in both branches.
Yeah, any points in history here, there's a unique commit ID, and it represents the full history leading up to that point in time. So if at any point I wanted to look through this history, if I wanted to go back to this point in time, I could make a new branch based on that commit. On the other hand, if I liked what I'd made here and I liked the change that I made here, but I didn't like what I made here, there's a command called revert. And so I could say git revert and give it that commit ID. And it will try to resolve the change in a way where it can pull out the change that you made. But this is actually a conflict. Oops. So it shows a conflict here because it couldn't revert that particular commit due to the fact that I had added additional lines right afterwards and it wasn't quite sure what to do. So it just shows me one version has that, one version has that. Which do you want me to keep? And you just edit out and leave behind what you want. And then you can tell it, you know, get revert -- continue. But it's telling me you didn't actually fix it, so that's fine.
So when it gives you that, it actually is, if you go back to your file and Mac,
Yep.
it actually nice and sets like it shows testing and all that. Like,
Yeah.
so we're not supposed to edit the stuff that they added in.
No, actually you are.
You are.
This is just to help you. It's showing you that the head is the commit that you had most recently, and then the parent of the commit that you're reverting is shown here. So it's showing that before that particular line of code was added, we had this, now we have this, and so it's just,
And you put that stuff in next to where your conflict has, like you have a 500 line program that you're editing, and your conflict is at like 320 or something. It'll do this sort of stuff right around 320. Right?
yeah. Yeah, but a lot of editors will actually have like, Visual Studio has buttons for this where you just click next conflict and it jumps down.
Yeah.
And then Emacs will just highlight it. I don't have my usual configuration here, but it'll usually highlight it pretty nicely. Other than that, I can just commit it and say, whatever, commit it with the conflict anyways. And then if I wanted to create some kind of a branch, like new branch 2, and push new branch 2, there's also a way to do the merging in the interface. So this is kind of where the team dynamic of GitHub comes in that I can go to pull requests, and I can make a new pull request. I can choose that I want to make a pull request for new branch 2, and it'll, by default, choose to merge it into the master branch. So I'm just making a request that have this change where I reverted it merged from my new branch that I worked on into the master branch. And if I created that, now another team member can come in and they can go merge pull request for me if we were in the type of team where we wanted to have everybody's code reviewed before it made it into the main line. So there's a lot you can do with different workflows and different collaboration techniques. And there's a lot of power with the flexibility of Git. I think that's... Yeah, you can definitely do that. It might be a little bit tricky because, like, getting it, it's not like built in by any means, but you could probably hack it together. I've done it before. It's not like it's a little hard because you have to make it so that it does the pull, and then you only want to trigger the build if something actually changed.
Yeah.
But
You can always do it where like you have where when you're first starting out on your project or the make dot, first today or something.
yeah,
Put make start.
make update.
Yeah.
yeah.
Okay.
So yeah, a couple of further resources. The Student Developer Pack, like I said, you can get a free upgrade to your account. Normally it's $7 a month to have the 5 private repositories, so it's pretty nice. And then the Pro Git book is really good. It's available for free, but it's a real book that they sell in stores too. You can just read it for free online, so it's pretty nice of them.
If you don't have that, all your repositories are public.
Yeah, unless you want to pay.
Anyone can download it.
Yep, that's part of the spirit.
So there's other ones though that you can use with GitHub, like
Bitbucket?
is the
Yeah.
same sort of idea, but it automatically starts out as private, so it might be a little bit easier as a student, so you don't get caught with
Yeah, that's a good point. You don't have to have a student account with Bitbucket to do private repositories.
I don't know if it's but I don't know if it has as much codability. It does come with some nice apps for user interfaces for Windows, so format.
Yeah.
And
That's a good one.
if your membership expires, all your private repositories become public.
I'm not actually sure. That's a good question. I haven't faced that problem yet. So is there anything else that you want to know? We can go into specifics of anything like branching or something further. But I think we probably covered the overview pretty well. You kind of have to get into it and practice to get the flow of things, but eventually it becomes a real big time saver to be able to look back and see that history so easily. Yeah, it really helps to find that. Yeah, definitely. Yeah. Any changes that you've made since the last commit will be shown if you do git diff in the files that were already there. So it'll just show like the lines that have been added or removed.
So if you want to do something like, let's say you're working on a project that has several .h's and several .mps or something, how do you upload all those files in?
So actually one thing you can do is, you could of course, like if I had a.c and b.c and c.c, you could do git add a.c, b.c, c.c, etc. Yeah, and so you have to do it that way the first time, but once I've made one commit with those files, then if I make a change to any of those files, git status will pick them up as modified, and from that point I can actually just do git commit and give it -a. -a says all files that were modified automatically should be part of this commit. So you don't have to do the git add for changed files, but you still have to do it for like new files. So that's a big time saver too, is git commit -a and then just give it the message. And it adds whatever file changed, in this case a.c. Yeah.
So you are making a program, you're testing it, and you get it to a pretty stable place. And you add all those things into your repository on your computer, and then you push that, edit that workflow.
Well, actually you do git add, which adds them to the stage. You do git commit, which commits what's in the index, the staged area, to the repository history, and that's your local repository. So then you push your master branch that you have locally to the remote repository, and then it has the same history as your local master branch with that commit. So it's pretty much add, commit, push. and then pull before you start. Oops.
What are some terrible things that you've done in Git that you shouldn't?
So tracking generated files in Git can be a nightmare, because,
Like, you know, 8 on out and stuff like that.
well, I was thinking more like generated code, where it's kind of like based on the database schema, it was dumped code. This was in a Ruby on Rails application. And so the problem with that is it's fine to just like check in every time you make a change, because it's automatically generated, until you get a branch. And then when you try to merge two branches together, and you've been checking in this automatically changed code in both branches, when you merge it back together, it's a merge conflict. And you don't really care about the contents, because you're just going to regenerate the file again, but then your merge didn't go through automatically, and you have to resolve the conflict, and that's a bit of a headache. So what you can do for that is there's a file called .gitignore, and anything that you list in that file will be ignored by Git. And just don't check in automatically generated code. That's the easy solution. And just have it rebuilt each time you check it out. But yeah, other than that, you can definitely get in some nightmare merges where it's pretty difficult to resolve just because the code's diverged so much. But the only way to resolve that is to collaborate more and keep your branches in sync with each other on big teams. Yeah. Yeah. Tell each other when you're working on similar areas of the code base. Tell each other when you make the commit update, there's changes.
Is there a way, you know, say you do this online if you're working on a team, to like automatically email members of the same team if you have a new commit or anything like that?
Yeah, there definitely is. I think it's like a built-in GitHub feature even. Let's see. Why is my keyboard not working? That's strange. So in the settings for the repository, there's webhooks. And I think, no, that's actually something different. Maybe it's a service. Email? Yeah. Okay, there's a service that you can add for email. And so you just go to webhooks and services, add the service for email, fill out what you want sent to it, and it'll do it.
Cool.
Yeah, personally, I've actually used custom hooks for that always. I've kind of written my own code where it responds to the Git changes. Because one thing you can do is you can actually put in hooks where, like, before you make a commit, it'll run this chunk of code. Maybe it'll validate. It'll say, hey, you used, like, tabs when we meant to use spaces, and kick you out of the commit. So there's a lot of hooks that you can put into Git and customize it and add on to the flexibility. And that's how I've usually done it, is just writing my own.
That's a good way to keep it so that you guys are the same style, and when you're going through and reading through
Yeah.
a specific thing, it keeps it. Which I think that's really cool. And that's in Code?
Yeah, there's webhooks here, and then other things you can do is in .git, there's hooks. And so, yeah. Here there's a couple things. Yeah, basically self-explanatory. But you can set up those chunks of code and just rename the .sample and look at what they have there, because they might have something silly. But one of them that I have on one of the projects I was working on is it enforces the commit message, because I was just doing single line commit messages, like a single sentence, but there's also, that's like the subject, and then there's also like a body field, kind of, where you do an empty line and then you write a big paragraph with explanation. And so one of the projects I work on, they require you have both the short description and a long description for your changes and write it out. And so I think that's the commit message hook. It just checks that it's at least 3 lines long, and if not, it tells me I have to write more. It's pretty annoying. But
That's a good thing.
yep. Keeps the changes well documented, so.
Yeah. I used to try to work in industry, and the worst documentation ever.
Yeah, our team lead on my team at my internship actually just always does empty commit messages.
Oh,
Never explains his changes.
it's just return, return, return.
Yeah, it's like, I don't know what he even was doing that for, but okay.
That much water.
Yeah. But whatever. It works for him. He remembers why he made the change.
That's why team selection is a good thing.
Yeah. All right.
Cool.
So thanks for coming, everybody.